Welcome. This is Geometry A, Unit 8, Lesson 6. We're going to examine in the coordinate plane two similar triangles. I've got an orange triangle and a blue triangle, and we're going to be looking at similar figures in the coordinate plane. And we're bringing back or remembering some of our transformation rules. There's translation, which is a slide, right? We can translate or slide by a vector. So xy becomes x plus h, y plus k, where the translation vector is hk. Okay. We can reflect across the x-axis. Xy becomes, across the x-axis would become x negative y. And reflect across the y-axis. Xy becomes negative xy. Those are reflections across axes. You can rotate 90 degrees clockwise or counterclockwise. Xy becomes y or negative yx. To think about that a little bit. So x and y switch places, and the first coordinate changes signs, negative yx. Okay, and so forth and so on. So we have all these rules that we've learned. And we're going to add to this list dilation, which is xy becomes kx times plus ky, right? And in this case, we're asked to prove that the orange triangle is similar to the blue triangle. And you'll notice that we have in fact two angles that are 90-degree angles and the 34-degree angle. So these two triangles are similar if I label these A, B, and C, and D, E, and F, D, E, and F. I would say that triangle ABC is similar to triangle DEF by the angle similarity postulate. By the way, we also know that angle E is congruent to angle B because angle B can be found by subtraction. And it's 180 minus 90 and 34. 90 and 34 is 124. 180 minus 124 is 56 degrees. So we know this is 56 degrees, and this is also 56 degrees by the triangle angle sum theorem. That is, all three angles need to add to 180. Okay, so that's brought up in this unit too. Now another thing that we need to do is demonstrate or illustrate the similarity of these two triangles by transformations. So I'm going to do a couple transformations. I'm going to start with the orange triangle ABC, and I'm going to transform it. So let's go pink here. That's a good contrasting color. I'm going to dilate ABC by a scale factor of 2. So A is 1 to the left, 2 up. So it's going to be 2 to the left and 4 up. A prime. B is 1 to the left and 2, 4, 6, 8 up. So it's going to be 2 to the left and 2, 4, 6, 8, 10, 12, 14, 16, 2 times. B prime. Okay, and C is 2, 4, 6, 8 to the right and 2 up. So it's going to be 10, 12, 14, 16, and 4 up. B prime. So dilate by a scale factor of 2, and we get this resulting triangle. And then there's obviously a rotation that went on here. Rotation. It looks like a rotation clockwise. Rotation clockwise of 90 degrees, or which would be equivalent to a rotation counterclockwise of 270 degrees. It can be used as well. So rotation clockwise. Let's change colors to green here. Clockwise, 90 degrees, or that's negative 90 degrees. Okay, so let's do that here. Instead of 2 left and 4 up, we're going to go 4 right and 2 up. A double prime. B is 2 left and 2, 4, 6, 8, 10, 12, 14, 16. So I'm going to go 16 right, 2, 4, 6, 8, 10, 12, 14, 16, and up 2. There's B double prime. And then C is going to be off the chart here. Okay, but it's going to be 16 and 4, so it's going to be 16 to the right and 4 up becomes 4 to the right and 16 down. 2, 4, 6, 8, 10, 12, 14, it's down here. Okay, so our triangle is going to be looking like this after a rotation of 90 degrees about the origin. Okay, off the charts there. It's going to be parallel to EF, so I'm just going to draw a line parallel to EF that goes through B. Yeah, not too far off the page, but just a little bit off the page here. Okay, and then we want to translate. Now we can tell how we're going to translate. Let's go yellow. Translate. I'm going to use a vector. So A double prime goes right 2, 4, 6, 7, up 2, 4, 6, 8, 10, 12. So right 7 and up 12. Translate up right 7 and up 12. So those are the transformations that map the orange directly onto the blue. So that's some of the math that you're going to be doing. I did pick or create a problem that was probably a little bit more complex than much of what you're going to answer, but hopefully that helps.